Hey everybody, Dr. Phil here. This is going to be a video that talks about sampling design. So let's go ahead and jump into it. All right, so the first thing we'll talk about is the steps in sampling design. So think about like designing the sample, who you're gonna target, what firms, what entities, what segment of the population perhaps, where they're located. So the first thing we'll do is define the target population in case. We'll define the population parameters, so like the key statistics, if you will, about the population. Define and evaluate the sample frames. We'll define the number of cases, like how many, what do we need in the sample, how many to make it kind of robust. Define the sampling method and define the selection and recruiting protocols. So the target population, and we could be looking for any one of these. We could be looking for, more than one of these, all of these, maybe perhaps more things that, excuse me, not even mentioned here. So text and records, settings, objects, events, organizations, people. These are all things that these are all things that the target population would have. One of the key questions for us is just going to be, you know, how many can we sample? How many can we afford to sample? Um, just a quick review here of data types. Remember nominal. Think about like names. The data that's a characteristic data is classification. Examples would be things like faculty, staff, and student, right? It's kind of got a name, if you will. Ordinal is classification and order. So in their example, like medium, medium well, medium rare, example for steak. Interval, classification, order, and distance. So how rated last restaurant experience on a scale of 1 to 10, 1 being very poor and 10 being exceptional. And then ratio, classification, order, and natural origin. Those could all be ratio. And then the average dollars amount spent per person for the latest restaurant dinner. So here we have a target. Well, we'd start by defining the target population in case, define the population parameters, define and evaluate the sample frames, define the number of cases, and then define the sampling method, and then define, as we said before, the selection and recruiting protocols. I'll probably come back to the number of cases because if you're doing a quantitative study, that is very important. So for the sample frame, we're going to list the elements in the population, like what do we want them to have? Are they complete and correct? The error rate does increase over time, so we have to kind of be mindful of that when we're doing our sample. We may include elements that must be screened out, so we may have to remove certain things. International frames are most problematic because you get into this, when you go from like one country to a different country, there's a lot of different things that come up. Problems with the sample frame, and there's more than these, but these are some of the common ones. An incomplete list, perhaps the list is out of date. The list may be too inclusive, maybe as strange as or as funny as that sounds, or the list is just inappropriate and it's not really, what you need. Communities, there may be people that are digitally literate. They may be loyal to the company. They want to share their ideas and concerns. Could be public or private. Um, and it does mean fast, cheap answers. And it's certainly an innovative way to get a group of people. But the problem, or one of the problems you run into there is you don't know that how much divergence of thought you're really going to get. Step four in sampling design. Um, so we talked about like defining the target population in case, the population parameters. What are those things that you're sort of looking for it to include? Define and evaluate the sample frames, the number of cases. Again, I'll speak more to that in a little bit because that's super important. The sampling method obviously is important, um, and define the selection and recruiting protocols. So why use a sample? Well, it's lower cost. It's greater accuracy in some ways. It wouldn't be as accurate as, sampling the whole population, but that's usually too expensive and too time consuming. The availability of elements, uh, excuse me, because it's easier to, survey a sample than a population, obviously, and it's also much quicker. So what is a valid sample? Well, a valid sample should be accurate and it should be precise. It should really what we should be saying here is it should represent the population. Because if you get a sample that doesn't represent the population, then you don't have a good sample, right? You don't have what's called a representative sample. That's going to be a problem because then any conclusions you draw based on what your experience with the and what you found out about the sample is not going to apply to the population. So sources of error. So we have we kind of split this between sampling error and then non-sampling error. So sampling error is the sample estimate is not the population parameter. That's kind of what I was just speaking to a second ago. Non-sampling error can deal with the sampling method was perhaps inappropriate. Maybe there were there were errors in the measurement instrument, and perhaps there were also behavioral effects. So when to use a larger sample? Um, if I'll probably start here with desired precision because it probably makes sense to you, right? The more people, the more you sample, the bigger the sample, if you will, as a percentage of the population, the more accurate it's going to be, right? Um, that can also cut down the small error range. It's going to help increase your confidence level. It may mean you have to increase the number of subgroups, possibly, not necessarily. And then hopefully the variance between the sample and the population would then be smaller. But that's good, but with that comes, of course, more cost, more time, more analysis, etc. So simple random sample, the advantages is it's easy to implement with random dialing if phoning. Disadvantages, it requires a list of population elements. Of course, it's time consuming. A larger sample is going to be needed. It produces larger errors, and it also has a higher cost. For a systematic sample, I should say, advantages are that it's simple to design, it's easier than simple random, and it's easy to determine the sampling distribution of the mean or the proportion. The disadvantages, the periodicity within the population may skew the sample and results. That's true. Trends in the list may bias the results, and there's also a moderate cost. And then stratified. So think of like stratified as in like strata, like groups. So stratified advantages would be control of the sample size in the strata, increased statistical efficiency. It provides data to represent and analyze the subgroups. You just heard me say groups. So think of like strata as groups, and then enables use of different methods in the strata. Disadvantages include increased error if subgroups are selected at different rates. It's especially expensive if strata on population must be created, and it's also a high cost. So stratified is good. Maybe if the sample is going to be pretty divergent, you might want to kind of like break them into groups with similar characteristics, or maybe it's a just a very large sample, and you wish to break that group down. And the good thing about the stratas is these sort of groups you can actually run separate analysis on the groups, and then you can also run like a big analysis if you desire. All right, that's it for this video. Short and sweet. Thanks for watching, and I will see you all in a future video.